take a look at the following problem. Do you remember how you would solve something like this? So if the first thing that popped into your head was cross multiplication, then that is definitely one way that you could solve this problem. Like you could multiply 3 times x, you get 3x, and then 7 times 5, and you get 35. Divide both sides of this equation by 3, and you get the answer that x is equal to 35 over 3. Okay? So by using cross multiplication, this strategy that you've learned maybe like back in middle school, you used it a lot in geometry when you were solving proportions. We can now take this strategy and then apply it to rational equations, which we'll learn about today. Okay, so again, one of your strategies that you can use is cross multiplication. Second strategy that we will also look at today is that you can rewrite the equation so that every term has the same denominator. Okay, and then you're actually allowed to cross out the denominators and leave just the numerators to solve. So let's look at this first problem, and I'm going to apply our first strategy to it. So I'll use cross multiplication to solve this. Now, if you look at this right away, I don't have 2 fractions on both sides that I can cross multiply. However, if I look a little closer at this 5, I recognize that there's always a 1 underneath every number or variable that I encounter. So there's an invisible 1 that's underneath this. And I can think about that, especially when I'm cross multiplying right now. So I can do 3x plus 1 multiplied by 1. Okay? And that gives me 3x plus 1. Then if I'm cross multiplying the other side, I have 5 multiplied by x minus 1. Remember that if you have a subtraction or addition symbol, there's implied parentheses around this, and I have to make sure that I'm taking this 5 when I'm multiplying it and I'm distributing it to both of these terms. So I'm going to get 5x minus 5. Now I can easily solve this. This is just like a simple equation. So if I subtract 3x over to the other side, I get 2x. And let's say I add 5 over to the right side. So that gives me 6. So now I get an answer of x equals 3. So with rational equations, we also have to check for extraneous solutions. And we've done this so far. I think this is the 3rd unit that we've had to check for extraneous solutions. Remember, you had to do this when we were working with radical equations, when we were working with log equations, and then now when we're working with rational expressions. In all 3 of those types of equations, you always have to check for extraneous solutions. Okay? So if I plug 3 back into this, just to check and see if it works, well, 3 times 3 is 9, plus 1 is 10, and then I have 3 minus 1, which is 2, and 10 divided by 2 is definitely equal to 5 over 1, or just 5. Okay, so 3 works as our solution. That is definitely a solution. All right, so that's using cross multiplication. Now, if we were going to use our second strategy, we can come over to this equation. Once again, we recognize that this 5 here has a 1 underneath it. Okay, so the way that my problem is right now, I can't cross multiply. Okay, if I was going to cross multiply, I would have to make sure that I'm adding this term together with this term before I can cross multiply. Okay, and everything that we've learned from the very last lesson, remember we learned about how we can only add rational expressions if they have the same denominator. Okay, and right now these don't have the same denominator, so I can't add them together. So here's what we would do using some strategies from the last lesson. So if I rewrite this, I have 5x over x minus 1 plus 5 over 1 equals 15 over x minus 1. So if I want these to have the same denominator, so I'm using my second strategy, so I'm going to rewrite the equation so every term has the same denominator. So if I want this 1 to have the same denominator as these x minus 1s, I'm going to multiply just this fraction by x minus 1 over x minus 1. So check this out. When I do that, I have 5x over x minus 1. Remember, we are distributing the numerator. So we get 5x minus 5 all over x minus 1. So now every one of my terms has the same denominator, okay? And because they all have the same denominator, I'm allowed to go in here and just cross all of the denominators out, even if they're on the other side of the equal sign. So all the x minus 1s are completely gone. You can only do this if they're all the same. And then I'm only left with the numerator. So I have 5x plus 5x minus 5 equals 15. Add the 5x's together, I get 10x, add the 5 over to the other side, and I get 20. So I get an answer of x equals 2. Okay, so that's using your second strategy. Once again, we want to plug this back in to check and make sure that it works. So plugging this in, I get 5 times 2, which is 10. 2 minus 1 is 1, so I get 10 over 1 plus 5 equals 15 over, and then plug in the 2 again here, and that just turns to 1. So yeah, definitely 10 plus 5, because this is just a 10. 10 plus 5 equals 15. So that is a solution. We're totally good. All right, with these two problems, I'm going to encourage you, especially for number 3. This is probably the most important problem to watch in this video. Is number 3. So I'm going to give you a second to try out number 3, unpause it when you think you've arrived at an answer. So I'm going to show you how to do this problem actually using both strategies, okay? Just to show you which one is more advantageous in this problem to use. So let's say I was going to use cross multiplication, okay? Let's go for it. So I have 3 multiplied by x squared plus 2x minus 8. So I get 3x squared. Remember, I'm distributing this to every one of those 3 terms. So 3x squared plus 6x minus 24. Okay, now with the x minus 2 and x minus 1, because those have implied parentheses around them, right? I have x minus 2 multiplied by x minus 1. I need to FOIL these together in order to get my answer. Okay, so I get x squared minus 3x, and I got that from the negative 1x and the negative 2x if I combine those together, and then plus positive 2. Actually, let's do this. Okay, so that's what I've got after I'm done cross multiplying everything. The next thing I want to do is let's take all of the terms and move them over to one side of the equal sign. It doesn't matter which one you decide to move it to, but I'm going to decide to move all of these blue terms over to the right side of the equal sign. So I'm going to subtract x squared to move it over, add 3x, and subtract 2. So I'm going to do all 3 of those things at the same time. So subtract x squared, add 3x, and subtract 2. So that gets all 3 of these terms to cancel out. So I'm just left with 0 on the left side. And I have 2x squared plus 9x minus 26. So now, from this problem, the way that this has turned out is I have a quadratic here that I can now factor and then find the solutions from that. So I'm going to use the swing method where I do 2 multiplied by negative 26. So 2 times negative 26 gives me negative 52. And then I have x squared plus 9x. So now that this is a simple ABC, I can factor this by thinking of 2 numbers that multiply to make negative 52 and they add to make 9. So let's see, I can do, well, 52 divided by 2 gives me 26, and 2 and 26 can't combine to make 9. Let me try another even number, so let's try 4. So if I do 52 divided by 4, I get 13, okay? So 4 and 13 can definitely combine to make positive 9. Only if the 13 is positive and the 4 is negative. Awesome. Now that I've done that, the very last step of the swing method is I have to divide both of the numbers by 2, since that's what I swung over. So since this divides cleanly, I get x minus 2. The other one, it doesn't divide cleanly, so I have to take the 2 and move it up to the front. So I get 2x plus 13. Okay? Leaving me with my final solutions of x equals 2 and x equals negative 13 halves. All right. Now that I'm done solving this problem using cross multiplication, I have to see if any of these are extraneous. So right away, I can tell that one of these answers is not going to work. It's definitely extraneous. Okay. So the one that is going to be extraneous is x equals 2. And the reason for that is if I were to plug this back in to my original equation, right when I plug it back in here, okay, that's going to make this denominator turn to 0. And that is a no-go. We cannot have denominators equal 0. So this one is extraneous. It's not a real solution. It's a faker. And my only real solution from this is x equals negative 13 halves. And you can double check that, plug that in to make sure that that works. But that is definitely your solution. All right, so that was using cross multiplication. Let's actually try our second strategy on this problem and see if that is maybe a little bit faster than doing it this way, okay? So let's erase all of this. And now I'm going to apply strategy number 2, okay? So to do the second strategy, what I'm first going to do is try to factor this denominator here. So I can see the factors a little bit more clearly. So I have x minus 1 all over. Well, let's see. This is going to factor into 4 and 2, where the 4 is positive, 2 is negative. Okay, so I see that from both of these rational expressions, they both have an x minus 2 in common, okay? They both have those as their factors. But to make them have exactly the same denominator, I'm going to need to take this expression and multiply it by x plus 4 over x plus 4, and then they will have exactly the same denominators. Okay, so let's distribute the 3 to both of these terms. So I get 3x plus 12 all over x plus 4 multiplied by x plus 2 over x plus 1, and just rewriting all of that. Awesome. Okay, so all I did, I just distributed that 3 to these two terms, and now I have the same denominators for both of these terms. So according to my second strategy, I can cross the denominators completely out. All the denominators are gone. So I'm just left with 3x plus 12 equals x minus 1. And from solving this, I subtract x from both sides, so I get 2x. I subtract the 12 over, so I get negative 13. And then I get my solution of negative 13 halves. Okay, so stopping to think about this, I don't know about you, but it seemed that this strategy was a lot less work than doing cross multiplication, okay? And also, when I solved this, I didn't get that answer of x equals 2. I didn't get that extraneous answer that popped out of using the second strategy. It only came into my answer when I was using cross multiplication. So the rule of this problem, at least, is if you can use the second strategy, I find that most of the time using this one is a lot less work, typically, and it really doesn't make extraneous solutions appear at all. So cross multiplication is the only one where you have to really worry about an extraneous solution appearing, okay? The second strategy, you're usually not going to have any extraneous solutions that pop up, okay? So if we're going to apply that strategy one more time for this problem, so again, I could use cross multiplication, I definitely could. But instead, if I was to factor this denominator, so let's say I factor out an x from both terms, so I get x multiplied by x minus 1, since I factored one x out, and it's equal to 1 over x minus 1. So in order to make these denominators the same, I just need to multiply this fraction by x over x. So you might already see what's happening here, but when I multiply this, so now they have the same denominator, and when I cross the denominators out, I'm simply left with x equals 2, okay? So if you try to do this through cross multiplication, doing it this way is definitely a lot less work at the end of the day. And so we can verify by plugging this in that x equals 2 is definitely a solution. All right, so that's pretty much a look at those two different strategies that you can use. The very last thing I want to look at is sometimes if you have word problems, there might be an extraneous solution that appears from a word problem because of the context of the problem. So if we were reading this problem, it says to find the average speed, x, of a particular canoe in still water, here's the equation, okay? So someone was so nice, they decided to already solve this for us. So it says, when solved, the two answers are x equals -1/2 and x equals 2. Which solution is extraneous? And then explain why in the context of the problem. So if we read back to the beginning here, it says that x was the average speed. Okay, so x is speed here. And then for x, for our speed, because x is speed, or average speed, for one of the answers we got -1/2 and the other one we got 2. So speed can only be positive, okay? So if you don't remember learning that before, that's okay, but speed has to be positive. So this solution right here is not going to work. This is definitely the extraneous one because of the context that speed cannot be negative. Okay, so x equals -1/2 is extraneous.